Today we'll begin the process of factorising polynomials. Remember, the reason we factorise is to get it into this form, let it equal 0, and then use the null factor law to solve. So the process that we're going to use today will help us get polynomials into this form. So the notes go on to introduce the remainder theorem, and I didn't really go through this in class. This is a little bit of an explanation of how it works if you're interested. We're going to go straight in and use the process. Alright, so using long division divide this by this. Okay, so what we'll do first of all is let p of x equal 3x to the 4 take away 9x squared plus 27x take away 8. Alright, now I'm going to use the remainder theorem to anticipate what the remainder will be. So that's going to be 3 times 16 take away 9 times 4 plus 54 take away 8. That's going to be 48 take away 36 plus 54 take 8. This is going to be 4, 8 is 12. 12 onto that is 66. 66 take 8, I've reached my mental capacity there, is 58. Okay, let's just check that on the calculator as well. So shift, oh, I've lost my shift keys, disaster. Okay, define f of x equals 3x to the 4 take away 9x squared plus 27x take away 8, and f of 2, 58. Okay, that checks out. Right, so now what we'll do over here is we'll run some long division on this. I'll just change pen color so you can see it. That's the worst straight line ever. Alright, let's go with red now. Okay, so the way we use long division, recall, is we're going to go x take 2 into 3x to the 4. Now here's a big tip. If there's no cube term, we'll make a cube term. 0x to the 3, and that acts as a placeholder for us and helps us kind of structure our long division. 9x squared plus 27x take away 8. Okay, so remember the process is you put x into 3x to the 4, which goes 3x to the 3 times, well I think it does anyway, and re-multiply it back out. So 3x to the 3 times x is 3x to the 4, and times negative 2 is 6x to the 3. Notice how the cube terms now line up nicely with each other. Okay, so that's going to be 6x to the 3, take away 9x squared. So x goes into 6x to the 3, 6x squared times, re-multiply it out, 6x to the 3, take away 12x squared. Okay, we've got negative 9x squared, subtract negative that, which is 3x squared, bring down the 27x from there. Alright, x goes into 3x squared, 3x times, 3x squared, take 6x. Okay, we've got 33x, bring down the negative 8. That's going to be 33. 33x when I re-multiply, 33 times negative 2 is negative 66. Brackets subtract. Right, so I've got negative 8 subtract negative 66 on negative 8 plus 66, which just so happens to be 58. Right, so notice the remainder there and the remainder there. So we've got exactly the same remainder. Alright, so we'll state what happens when I divide it. So x take 2 goes into that this many times with this much remainder. So we're going to say that it is, or the quotient is 3x cubed plus 6x squared plus 3x plus 33 plus the remainder, which is 58. And what we were trying to do is put x take 2 into that. Alright, using equating coefficients, divide that by that. So it's the same problem, except it's a different technique. Alright, and what I did was I skipped that one, and I'm going to go back to that one later. Alright, here's the only time I really use long division in maths methods, is to help us out with expressing a linear over a linear in this form here. So what I'm going to do is go x plus 3 goes into 3x take 4. That goes in 3 times. Re-multiply it out. 3x plus 9 brackets subtract. Right, negative 4 subtract 9 is negative 13. Alright, so what that is that goes into that 3 times with negative 13 left over, which we were trying to put in x plus 3. So we got it in the right form. So a is equal to 3 and b is equal to negative 13. There's a way to test on your calculator. So you do prop frac, so interactive transform prop frac, and that'll get it into the required form as well. All right, show that x plus 1 is a factor of that cubic function. Well, don't use long division to do it, okay? To show that there's zero remainder, use remainder theorem. So we're going to say let p of x equal x cubed take away 4x squared plus x plus 6. All right, now we'll do p of negative 1. So if it's a factor, if we pop in p of negative 1, it should be 0. So let's show it by actually working it out. So negative 1 cubed is negative 1. Negative 1 squared is 1, take 4. Negative 1 goes in there, plus 6, and that is equal to 0. So we're going to say, therefore, x take 1, or x plus 1 rather, is a factor. Alright, so just some advice. When we're asked to factorize something like this, hopefully you can see that the linear factors are x plus 2 and x take 2. So you can see there, to make a 0 remainder, it'll be 2 and negative 2, because both of them when squared will make this 0. So we don't really need to use the whole factor theorem. So we only use it when it isn't easy to find it. And when attempting to factorize an equation first, try to find a common factor. You may also be able to factorize by using grouping 2 and 2 first. Right, so let's do this one here. Solve the following equation for the unknown. All right, so we need to find x. So before you start throwing out at long division and remainder theorem and all of that sort of stuff, what we're going to do is note that each term has a common factor of x squared. So let's pull it out. X squared take 9, and basically this is ready to go now. So we can apply the null factor law here, which is x squared equals 0, x equals 0, x squared take 9 equals 0, x squared equals 9, x is equal to plus or minus 3 when I root both sides. Right, factorize this and hence solve p of x. Alright, so what we're going to do is attempt to find a linear factor, and to do that, what I do is I just attempt p of 1. Okay, I look at this last term here, which is a 30, and I try factors of 30. So what I'm going to do is start at 1, then go negative 1, then 2, negative 2, 3, negative 3, 5, negative 5, until I hit a factor. And usually it happens pretty early. So p of 1 equals 1, take away 4, take away 11, plus 30. And what we can see is that's not equal to 0. Okay, so p of, or x take 1 is not a linear factor. Now what I'm going to do is try p of negative 1, and I think when I did it in class this was it. So negative 1 goes in, which is negative 1, take 4, take plus 11, plus 30. No, it wasn't. So that is not equal to 0, so that's not a factor. So let's try p of 2. I think this was it. 8, take away 16, take away 22, plus 30. So this equals negative 38. 8 and 30 is 38, equals 0. Therefore, x take 2 is a factor, because we got 0 remainder. Okay, so here's where you could start the process of long division if you wanted. So you would do x take 2 goes into x cubed take away 4x squared take away 11x plus 30, knowing that as you drill down on this, what would happen is it's going to come out with a 0 remainder. Okay, but I don't really like doing long division, so what I'm going to show you is the equating coefficients process. So it's x take 2 is our factor, And what's going to happen is to make the cube term, what this is going to be multiplied, the linear factor is going to be multiplied by, is some sort of quadratic. Now, x times x squared is going to give us the x cubed term. And then I just go, all right, negative 2 multiplied by what gives me positive 30? Well, the answer is going to be take 15, because negative 2 times negative 15 is positive 30. The middle term is the one that we don't know. We're going to say that that's going to be bx. All right. Now, here's the equating coefficients process. What I'm going to do is work out, if I remultiplied or expanded this out, what are the things that would make an x term? All right, well, there's two things. It's going to be negative 2 multiplied by bx, okay? Now, negative 2 multiplied by bx is negative 2bx, but because I'm only looking at the coefficients, I'm going to write that down as negative 2b. All right, the other way I get an x term is it's going to be x multiplied by negative 15. All right, so that's going to be negative 15x, but because I'm only looking at the coefficients, I'm only going to write down negative 15. Now, what's that need to equal, or what do the coefficients add together to be? Well, that's found by looking at the coefficient of the x term in the original form, which is negative 11. All right, so I've got negative 2b. What I'm going to do is solve for b now. So I'm going to add 15 to both sides, divide by negative 2, b is equal to 2. So that means p of x equals x take 2, x squared, and not bx anymore because I know it's negative 2. So negative 2, I just wrote it again. Negative 2x take 15. Okay, now we need to solve this, so we're not done yet. So what I'm going to note is this here is a quadratic, so let's see if we can factorize that, which it looks like it will nicely. 5 and 3, and it's going to be negative, so it's going to be x take 2, x take 5, x plus 3. What we'll do is we want to solve this, so it's going to be when p of x equals 0. This step is a must include, all right, because you can't just apply the null factor law when it's equal to p of x. It's got to be p of x or y equals 0. So let's apply the null factor law. X is equal to 2, x is equal to 5, and x is equal to negative 3. There are x-intercepts. Okay, so factorize this and hence solve p of x. So we're going to go down the same path. So p of, so I think from memory I did this in class, and I think it was p of negative 2. So I would have tried 1 and then negative 1 and then 2 and then negative 2. All right, so from memory I think it was negative 2, but I'm going to try it again anyway. Negative 2 equals negative 8 plus, that's going to be 4 plus 18, take 18. Ooh, hang on. Oh, that's smart. That's 8. All right, so my mistake. So they cancel out and they cancel out, leaving us with 0. Therefore, we're going to say x plus 2 is a factor. Alrighty, so what we can do now is run the equating coefficients process. So we'll go p of x equals x plus 2 multiplied by something. Alright, now it's going to be x squared there, and it's going to be 2 multiplied by what gives me negative 18. That's going to be positive 9. No, negative 9. Negative 9. Negative 9 plus an unknown middle term. Alright, so same as last time, what I'm going to do is work out how I'd make an x term. Okay, so the x term is going to be made by doing 2 multiplied by bx, but I'm only interested in the coefficients, so that's 2b and x times negative 9, so that's negative 9 as the coefficient, equals, coefficient over here is negative 9. Add 9 to both sides and I'm left with 2b equals 0, b equals 0. So what we're going to say is p of x equals x plus 2, x squared take 9. That means, I just jumped the gun there. Let's go over to here. We're going to say 0 equals x plus 2, x squared take 9. Let's run the null factor law. X is equal to negative 2. X squared take 9 equals 0. X squared equals 9. X equals plus or minus 3 after rooting both sides. All right. Now, when you have to factorize addition and subtraction of perfect cubes, there is an identity that you can use to help you. Okay, so this is x cubed take away a cubed. What you do is you use this identity here. It tells you what to put in what spot. There's also an identity for the addition of perfect cubes. Okay, now big confession, I've got no idea what these identities are, so I never use them. All right, and what I do is I just use the process we've just described there, which is the equating coefficients process. So to do it, let's just get started. So what we're going to do is do p of 3 and just check what the remainder is. That's going to be 27 take away 7, which is 0. So we're going to conclude that x take 3 is a factor. All right, now let's use the equating coefficients process. We've got x take 3. Then I'm going to work out how I'm going to make that, which is x squared rather, plus bx, a middle term that I don't know, and negative 3 multiplied by what gives me negative 27. The answer is positive 9. All right, so let's get the b term as we've done so far, which is negative 3b, that by that. Then we're going to do x by 9, so that's plus 9 equals. Now, what's the coefficient of the x term here? Well, there isn't one, but it would be 0x. So it's going to be 0. Negative 3b equals negative 9b equals 3. So therefore, what we're going to say is p of x equals x take 3, x squared plus 3x plus 9. All right, we're ready to use the null factor law. So we're going to say that x is equal to 3. Now this one here, all right, here's what I'm going to write down for this. X squared plus 3x plus 9 is not equal to 0 as the discriminant is less than 0. Now how do I know this? Well, for a perfect cube, if you consider the graph of it, the graph of this is the standard inflected cubic moved down 27 units. So the inflection point happens at negative 27. Now notice that we get one x-intercept, okay, which means that this cannot produce any other x-intercepts. And when this can't produce x-intercepts, what that means is it must be a parabola that's either above the x-axis intercept or below the x-axis, not intercept, but above the x-axis or below the x-axis, which essentially means that the discriminant has to be equal to 0. So I'm not going to check this one because it never will equal 0. Okay, but I've got to still show evidence why I considered it. All right. So let's do this one here. So I've got, let's try p of 5 equals no, it's p of negative 5. So p of negative 5 equals 0. Therefore, x plus 5 is a factor. So we're going to do the same exact thing as before. P of x equals x plus 5, x squared plus bx, a middle term that I don't know yet. Now 5 multiplied by what gives me 125? It's going to be 25. Okay, now this term here, let's do the x term. So I've got 5b plus 25 equals 0. Okay, because the x term over here is 0. 5b equals negative 25. B equals negative 5. So p of x is equal to x plus 5, x squared, take 5x plus 25. All right, again, we know that this is an inflected cubic that goes up there. So we've only got the one x-intercept, which is at x. Ooh, I dumped the gun there. I really want to solve this thing, but I've got to include this line. 0 equals x plus 5, x squared, take 5x plus 25. X is equal to negative 5. x squared take 5x plus 25 cannot produce solutions. So we're going to say not equal to 0 as last time. Discriminant is less than 0. Alrighty, so this problem here, given that p of x is this, and a factor of it is this, when it's divided by this, there's that remainder, determine a and m. Okay, so if this is a factor, if x plus 1 is a factor of this, then p of negative 1 will equal 0. Okay, that's what happens when things are factors, is you get 0 remainder. Okay, and if it's divided by x take 3, i.e. if I do p of 3, what I'm going to get is 24. Now that I know this, what I'm going to do is use these ideas to form my two equations. So I'm going to drop negative 1 into the function. So negative 1 plus a, take away m, take away 6, equals 0. A take m equals 7. Negative 6, take another 1 is negative 7, add 7 to both sides. All right, cool. P of 3 equals 24. Okay, so let's whack 3 in. So we've got 27 plus 9a plus 3m take 6 equals the remainder, 24. 21 plus 9a plus 3m equals 24. 9a plus 3m equals 3. Okay, so what I will do is I'll multiply that by 3 and run an elimination. 3a take away 3m equals 21. Or I could have just divided that one by 3. Anyway, let's just run with this. So I'll call that equation 1 and equation 2. Now what I'm going to do is eliminate the m's, and the way I'm going to do that is add them. So I'm going to get 12a equals, nice integer values, equals 2. So 21 and 3 is 24, 3a and 9a is 12a, those cancel out. So a is equal to 2. Now we're going to sub that into, let's sub it into this one here. So I've got 2 take m equals 7, negative m equals 5, m equals negative 5. All right, let's just quickly try that out on the calc. So I'm going to go and run a define f of x equals x cubed plus a 2x squared. So I've just put the value of a there. All right, so I've found that a is equal to 2. Take 5x, take 6. Okay, if I do f of negative 1, the answer should be 0 if I'm correct, and it is. If I do f of 3, the answer should be 24 if I'm correct. Bingo. Okay, the final thing we'll look at is the rational root theorem. And really, nothing changes here, but what we'll do is we'll have a look at this. So we'll follow our instructions. So define it. F of x equals 2x cubed, take away x squared, take away x, take 3. And what we'll do is we'll do f of 1. All right, and see what it is. So we'll do p of 1, p of negative 1, p of 3, and p of negative 3. All right, so we're looking again at that term there and trying to work out when we're going to get 0 remainder. Oops. Yep. All right, so f of 1 or p of 1, p of negative 1, no luck yet, p of 3, and p of negative 3. So all of them, or none of them, equal 0. So what that might suggest to you, or you might think, oh, we've got no factors, okay? But actually, does not have an integer solution, but could it have a fraction for a solution? So when factorized, what it will look like is something like this, which is a linear multiplied by a quadratic. Okay, so we've seen that sort of happens. So we're going to use some inspection to find that we'll end up with 4 options. So I'm just going to rewrite p of x equals something multiplied by something. Right, so here is what's going to happen. So we're going to either this can be 2x here, which means this will be x squared here. This could be take 1, which means that this will be plus 3. So that to that and -1 will give us that. So this is an option. Now the other ones we could get is p of x equals 2x plus 1, in which case what we would have is x squared and take 3. So this is also a possibility. P of x equals, now we could get 2x plus 3, x squared, and this would be take 1. And the final one, p of x equals 2x take 3, x squared plus 1. Right, how do I know I've exhausted all of the options? Well, if you think about it, that's the only way we can get a factor is we've already tried linear factors with like x take 1, x plus 1, x plus 3, and x take 3. We've already tried those ones. We've done them up here and none of them worked. So we know that x has to have a coefficient. The 2's got to be there, right? So now what we would do is note that if this is the proposed linear factor, then p of, and what we're going to note is that's going to be p of a half. All right, so the way we think about that is a bit like this here, or the standard ones over here where we find out, so p of -5 is x plus 5. So anytime we've got a coefficient other than 1 on this term here, on the x term, what that means is we're going to get a fraction as a possibility. So the next one is p of -1/2. This one here is going to be p of -3 on 2 and p of 3 on 2. And what we would do is test each of them by substituting in that. So what you'd have to do if this was non-calculator is actually put those fractions into this cubic. But there's no way I'm going to consider doing that. I'm going to do this on the calculator. So my calculator is just played up. All right, there it is reinstated. So what I'm going to do is define a function, f of x equals 2x cubed, take away x squared, take away x take 3. And I'm going to do f of a half, f of -1/2, f of -3 on 2, and f of 3 on 2. Whoa, way to leave it to the last minute. Okay, so p of 3 on 2 does equal 0. All of these don't equal 0. What that means is 2x take 3, didn't really need the brackets there, is a factor of p of x. Right, so we found a linear factor, even though when we tried p of 1, p of -1, p of 3, and p of -3, it didn't seem to work. Okay, so the factor is a fraction. Well, actually, it's not a fraction, but to work it out requires us to use this fraction here. All right, so let's factorize this thing here. So the first thing to do is note that p of x could be expressed in the form that multiplied by quadratic. Now, what I'm going to suggest to you is that this one here, if I tried p of 1 and p of actually let's write that down. So we're going to go p of 1 equals, p of -1 equals, p of 5 equals, and p of -5 equals. Now what we would find is that all of them don't give us 0, which means that x plus 1, x take 1, x take 5, and x plus 5, none of those are factors. but we're not going to give up yet. What we're going to do is try to find a different factor. Right, I'm going to do a fair bit of the legwork of this on the calculator. F of x equals 3x cubed plus 8x squared plus 2x take 5. Okay, f of 1, this is just proving it to you, f of negative 1, f of 5, and f of negative 5. So none of them work, okay? So let's go back to the drawing board here and work out what our factors could be. So it can't be just x by itself and x squared here. What we're going to do is note that this one is going to be the 3x, and this has to be the 1, because this, when I put it into the function to test the remainder, has to be a fraction. So that could be 3x, and we're going to go plus 1, which would mean that's negative 5. Now it could be 3x take 1, which means that that is x squared, and that is positive 5. Okay, it could be 3x take 5. That would be x squared plus 1. It could be 3x plus 5, x squared take 1. Alright, so these are our possibilities here. Okay, so what we'll do is we'll do p of each of them. Negative 1/3 is that one. P of 1/3 is the second. P of 5 on 3 is the third. And P of negative 5 on 3 is the final one. Okay, so f of negative 1/3, f of 1/3, f of 5 on 3, come on, f of negative 5 on 3, Phew, last one as well, equals 0, doesn't equal 0, doesn't equal 0, doesn't equal 0. Okay, so p of x equals, what was it, 3x plus 5. Okay, and now what we're going to do is get, so what's that one have to be? That has to be negative 1 plus bx. So we'll use the equating coefficients technique to get the coefficient there. So I've got 5 multiplied by bx, that's going to be 5b. 3 multiplied by negative 1 is negative 3 equals 2. 5b equals 5b equals 1. Okay, so p of x equals 3x plus 5 x squared plus x take 1. Alright, and we've factorised it. Alright, so fair few questions there to do. Okay, good luck with that.